By way of introduction, we want to review just a couple of things. So your warm-up questions started out with two triangles solving for the missing variable. And so your warm-up should have looked something like recognizing that these two triangles have internal degrees that will have a sum of 180. You should have added 42 plus 85 plus W equals 180. And now we're going to simplify 42 plus 85. And we end up with 127 plus W equals 180. We're still trying to isolate the variable, so our next step is to subtract 127 from both sides of the equation. And we're left with W equals 53. So for the first triangle on the left side of the screen, our value for W is 53 degrees. Now our triangle on the right, despite the fact that I used the same triangle shape, I changed the numbers up a little bit by adding that right angle down there. And we discussed in class that sometimes I will use a shape that doesn't necessarily look like a perfect right angle, but if it has the little logo that shows you that it is a right angle, that is me trying to make sure that you are paying attention to what is in that angle. And so for that particular problem, we're going to end up with 42 plus 90 plus Z equals 180. And so our 42 plus 90 simplifies to 132 plus Z equals 180. And we will subtract 132 from both sides. And we end up with Z equaling 48 degrees. That's our real quick review of the triangle sum theorem. Three angles within a triangle will have a sum of 180 degrees. And that's our triangle sum theorem. And that's our triangle sum theorem. And that's our triangle sum theorem. Using that triangle sum theorem, we can start to solve bigger problems like the one on the screen. And in this one, we have to start, it's kind of like putting together a puzzle. You've got to find where the most logical piece of information is. And here the most logical piece of information seems to be the triangle that looks similar to our previous problems. So you'll notice that our sample problem started with a triangle that had 42, 85, and W all in it. So we already know that the value of W is going to equal 53 degrees. We also know that W and X, if I were to draw just that portion of the shape where we have W and X, and we can see very clearly that there's intersecting lines there, and the line underneath the W and X is very straight, so it's going to have a total of 180 degrees. And if I were to draw the angle arch in here, we would see that that forms half of a circle, which is 180 degrees. And we know that W is 53 degrees. So the remaining portion of the arch, which represents X, has got to be 53 plus X equals 180 degrees. So we subtract 53 from both sides, and we're left with X equals 127 degrees. Now there's another important piece of information that we see in our intersecting lines, and that is a vertical relationship. So we have vertical angles, and that is an angle directly across within the intersecting lines. Now the reason I need to know that relationship is that's going to tell me that this angle over here is 53 degrees. So that now I have a 53-degree angle plus an 88-degree angle plus whatever y may be, but again, all three of those angles are going to add up to 180 degrees. So my 53 plus 88 adds up to 141 plus y equals 180. So my value of y then is 39 degrees. I'm going to go ahead and let you try this one on your own. Again, you need to look for the triangles within this shape. Now, there are really three triangles. One sliver of a triangle on the left, a triangle on the right, and then the big overall triangle that both of those two other triangles are resting within. Another definition that we need to know is relates to exterior and interior angles. Each exterior angle has two remote interior angles. A remote interior angle is an angle that is not adjacent to the exterior angle. And so you see the image on the screen, and I'll go ahead and draw another one here for reference. And our exterior angle is this angle over here, number 4. It's the angle that's touching the outside of the triangle and connects to the line coming from the triangle. Now, angle 3 sits right next to the exterior angle, so it cannot be a remote interior angle. Angles 1 and 2 are both removed from that exterior angle, and so they are the remote interior angles. And that knowledge will help us with our definition of the exterior angle theorem. The exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So as we get to practicing this, we'll notice that the measure of angle 1 plus the measure of angle 2, those two remote interior angles, will be equal to the measure of angle 4. So we now want to solve for a missing angle. Now, earlier this year, we talked about supplementary angles in the triangle sum theorem, so we could certainly find the value of x without ever knowing the exterior angles theorem. But the exterior angles theorem is going to help us get there quicker, and our goal in math is to learn as much as we can so that we can do the math correctly and quicker. Now, in this particular problem, we see two remote angles. Angle U and angle T are both remote angles. The exterior angle would be angle RVU with a vertex at V, and it shows it to be 120 degrees. So we now know that X, a remote interior angle, plus 50, my other remote interior angle, will be equal to 120, which is the exterior angle. Now we can solve for x very quickly because we have a one-step equation. Subtract 50 from both sides, and x will equal 70 degrees. This is a similar problem working from a different direction. Now we see our two remote interior angles are 50 and 70. So 50 degrees plus 70 degrees will equal the value of my exterior angle. And in this case, x is in the place of the exterior angle. So we simply simplify. 50 plus 70 is 120 equals x. That would be our solution. Now we apply that to our expressions. And since we're applying the exact same concept, we realize that angle P is 30 degrees is an interior angle, and angle Q, 4x plus 2, is my other interior remote angle. So we're going to have 30 degrees plus 4x plus 2. Those are the two values of my interior angles will equal the exterior angle. And in this case, the exterior angle is 8 plus 6x. Now, since I look at my parentheses, there's no negative signs or subtraction sign in front of either one, so we don't need the parentheses anymore. 30 plus 4x plus 2 equals 8 plus 6x. And we'll combine our like terms. 30 plus 2 is 32 plus 4x equals 8 plus 6x. And we've talked in class a number of times about moving the x's across the equal sign. Anytime we have x's on both sides of the equal sign, you have to add or subtract to move them. I'm going to choose to move the lower x value because if I move the lower x value, I'm still going to have a positive x value rather than ending up with a negative variable. So I will subtract 4x from both sides. 6x minus 4x gives me 2x. We still want to work on isolating that variable, so I'm now going to follow my reverse order of operations, subtracting 8 from both sides to where we will get 24 equals 2x. And then finally I will divide by 2 so that x is equal to 12. Now, knowing the value of x is very helpful because I could technically find the degree of measure for each angle on this image simply now because I know the value of x. I'm going to go ahead and let you try the next one. And assuming that you do all of your steps correctly, you should end up with the same answer, x equals 12.